Welcome to the SI Academy. In last class we discussed that the metals are reacting with water and some elements are reacting with cold water, some elements are reacting with hot water and some elements are reacting with steam and some other elements do not react with water at all. Next comes here what happens when metal react with acid. Next topics what happens when metals react with acid. We already learned that metals react with acid to give salt and hydrogen gas. We already learned in previous classes that when metal is reacting with acid, that will release salt plus hydrogen gas. This you already learned. When metal react with acid, that always releases the salt plus hydrogen gas. Here is given in the general form that metals dilute acid react with, that will give the salt and hydrogen gas. Let us find out next how metals are reacting with the acid. So collect activity 3.11, collect the metals samples except the sodium. So we have to collect here what we have to collect the metal samples except sodium, potassium. Again, if the samples are tarnished, rub them clean with a sandpaper. So put the samples separately in a test tubes containing dilute hydrochloric acid. Suspend thermometers in the test tube so that their bulbs are dipped in the acid. So you have to take a container, in that you have to take the samples and put in a beaker containing hydrochloric acid, and you have to suspended thermometer, check the whether it is a liberation of heat or not. Observe the rate of formation of bubbles carefully. Which metals react vigorously with the dilute hydrochloric acid? With metal, did you record the highest temperature? Arrange the metals in the decreasing order of reactivity with the dilute acids. You have to take different types of metals and that reacting with the hydrochloric acid, and which one produce bubbles and which one produce a greater temperature. That all type of observation you have to note down while reacting with the dilute acids, when metals reacting with the dilute acids. So what we conclude here means write the equations for the reactions of magnesium, aluminum, zinc and iron with dilute hydrochloric acid. So for example, so zinc is reacting with hydrochloric acid, it will gives the salt ZnCl2 plus ZnCl2 plus, again what is liberated here, hydrogen gas is liberated. Again next example, what is again is the magnesium Mg plus HCl, 2HCl, that is the 2Mg. So what will gives the 2Mg? So what is magnesium is 2Mg reacting with 2HCl, that gives the MgCl, 2MgCl Cl plus hydrogen gas will liberated. Again next, what is the third one? So iron and zinc, that will react with hydrochloric acid to produce a hydrogen gas. Hydrogen gas is not evolved when metal react with nitric acid. Very important question. Why hydrogen gas is not evolved when metal react with nitric acid? This is very important question. Why hydrogen gas is not evolved when metal react with nitric acid? Because it is HNO3 means nitric acid is a strong oxidizing agent. It oxidizes the H2 produced to water and itself gets reduced to one of the nitrogen dioxide. This is the answer for that. Why nitric acid does not produce hydrogen gas means nitric acid is the strong oxidizing agent. It oxidizes hydrogen to produce a water molecule and itself get reduced to one of the nitrogen dioxide and nitrogen oxide. So this is why the hydrogen gas is not evolved in the case of nitric acid. Very important question. What is that? Hydrogen gas is not evolved when metal reacting with the nitric acid. Why means you can write HNO3 is a strong oxidizing agent. It oxidizes the hydrogen to produce water, and itself get reduced to any one of the nitrogen dioxide, so nitrogen oxide. So that is why the magnesium, that is why nitric acid does not produce a hydrogen gas. Very important question. But there are two metals which can produce the hydrogen gas from the nitric acid. Which two metals are? Means manganese and magnesium are the two metals which can produce the hydrogen gas from the manganese, from the nitric acid. Which are the two metals? Magnesium and manganese react with a very dilute HNO3 to evolve hydrogen gas. Remember that these are the two metals which react with HNO3 to produce hydrogen gas. One more question: which two metals react with HNO3 to produce hydrogen gas? Means you can write magnesium and manganese. So two elements which are very reactive with HNO3 to produce hydrogen gas. Very important. So remember for 1 marks. Only two metals that react with HNO3, and that two metals are manganese and magnesium. Very important. Remember that this is the 1 mark question. So you must have observed in activity 3.11 that the rate of formation of bubbles was the fastest in the case of magnesium. So in the case of what is the bubbles formation in the activity 3.11, that magnesium forms the bubbles very quickly. The reaction was also the most exothermic in this case. So what is the exothermic? Means the reaction in which heat is released along with the formation is called as the exothermic reaction. What is exothermic reaction? So exothermic reaction means the heat is released. The main concept is that heat is releasing is called as the exothermic. Thermic means heat. So exothermic, heat is releasing means is called as the exothermic. The reactivity decreases in the order of magnesium, aluminium, zinc and iron. In the case of copper, no bubbles were seen, and the temperature also remains unchanged. This shows the copper does not react with the dilute HCl. So here the copper does not reacting with the HCl. And two type of question comes here: why nitric acid does not produce hydrogen gas? First question. And which two metals reacting with the manganese, reacting with the hydrochloric acid, reacting with the nitric acid to produce a hydrogen gas? Means there are only two elements called as the manganese and magnesium are the two elements react with the HNO3 to produce a hydrogen gas. And again one point, copper does not react with the HCl. Remember this is the again important point. Next again one more question. Aqua regia. What is the meaning of aqua regia? Means it is in Latin word it is called as the royal water. Aqua regia in Latin is called as the royal water. Is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Again very important one more question. What is aqua regia? Means you can write it is the freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So is called as the aqua regia. What is aqua regia? Aqua regia is the freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Again it is very important for 1 marks, and it is asked for in another type of question like that. What is the ratio of aqua regia? Means you can write 3:1. 3 is the 3 for hydrochloric acid, 1 for nitric acid. So remember that the ratio of aqua regia is 3:1. What is aqua regia? Concentration of hydrochloric acid and concentration of nitric acid. Remember that. Very important. It can dissolve gold even though neither of these acids can do so alone. So aqua regia is solution that dissolves gold, even though neither of these acids can do so alone. Aqua regia is the highly corrosive foaming liquid, is the one of the few reagents that is able to dissolve gold and platinum. So remember that the gold and platinum is dissolved by aqua regia. Very important. To gold and dissolves are dissolved in which type of solution, means you can say that aqua regia. Aqua regia is a dissolves the gold and platinum. So very important. What is aqua regia, means you can write concentration of hydrochloric acid and nitric acid in the ratio of 3:1 is called as the hydrochloric acid. And again different type of question arises for the aqua regia, means write the ratio of aqua regia, means we can write 3:1. And the aqua regia solution dissolves the which two type of elements, means you can write gold and platinum. Next, how do metals react with the solution of other metals also? So next, how do metals react with the solution of other metals? Next, activity 3.12. Take a clean wire of copper and iron nail. We have taken the clean copper wire and iron nail. Put the copper wire in a solution of iron sulfate and the iron nail solution of copper sulfate taken in test tubes. So what you have taken here, iron nail and copper. So put the copper wire in a solution of iron sulfate. So we have to take copper and iron nail, and copper was dipped in a or taken in a solution of iron sulfate, and iron nail is iron nail in a solution of copper sulfate taken in test tubes. So record your observation for 20 minutes. So you have to observe for this 20 minutes, and what we observed in this section you have to study here. In which test tube did you find that a reaction has occurred? So in test tube that a reaction is occurred, that we have discuss here. On what basis can you say that reaction has actually taken place? The reaction is completing, means in which case we are saying that, or on which basis we are saying that the action is taking place. Can you correlate your observations for the activities 3.10, 3.11? So write the balanced chemical equation for the reaction that has taken place. Name the type of reaction. So here what we have taken first, we have taken the iron. So correct, first we have taken as the iron, and that is the iron nail, plus what we have taken, copper sulfate solution CuSO4. Correct, we have taken iron nail and copper sulfate solution, that will gives the FeSO4, that is the iron sulfate, plus called as the Cu or copper. So we have taken the iron nails and dipped in the copper sulfate solution, and that will gives the iron sulfate and copper. This reaction is called as the displacement reaction. What type of reaction is a displacement reaction? Remember that. So iron is reacting with the iron nail is reacting with, or iron is reacting with copper sulfate solution, and it will gives the iron sulfate copper. So what type of reaction? This is called as the displacement reaction, is called as the displacement reactions. So we observed that reactions is called as the displacement reaction. So what is the displacement reaction? Means we can say that the more reactive element displaces the less reactive element, is called as the displacement reaction. What is displacement reaction? More reactive element always displaces the less reactive element, is called as the displacement reaction. So this is called as the displacement reaction. So reactive metals can displace reactive metal can displace less reactive metals from their compounds in solutions or a molten form. So reactive metals can displace the less reactive metals from their compounds, is called as the displacement reactions. We seen in the previous sections that all metals are not equally reactive. So we already learned that the metals of different metals or different kinds of metals do not having the same kind of reactivity. Some metals having higher or some metals having lower reactivity, some are very poor. So all metals having different reactivity. Like our human beings, all human beings are different in unique and different structure and different characters. Like that only all metals do not having the different reactivity. We checked the reactivity of various metals with oxygen, water, and acid, but all metals do not react with these reagents, so we are not able to put all the metals samples we had collected in a decreasing order of their reactivity. So we have taken different type of metals and we are reacted with that metals with water molecules and acid and oxygen. So in that some elements are reacting with oxygen and some elements are reacting with water and some elements are reacting with acid. So some elements are there but do not react with water as well as the and acid and oxygen. So that type of situations we cannot classify the elements or reactivity on these three categories: oxygen and water and acid. So displacement reaction. So we cannot classify the elements or samples on their reactivity towards oxygen and water and acid means then we will concluded that the which reaction is suitable or a correct or a will gives the precision of reactivity series means that reaction is called as the displacement reaction. So what is the displacement reaction means the more reactive element displaces the less reactive element is called as the displacement reaction. So the definition itself says telling that more reactive, more means this is the more reactive displaces the less reactive element, that is called as the displacement reaction. That will easily gives that the which one is the more reactant, which one is the less reactive element. So displacement reactions studied in chapter 1 give better evidence about the reactivity of metals. It is simple and easy. It metal A displaces metal B from its solution, it is more reactive than B. For example, any metal displaces from its solution means so the displaced element is less and displaced metal is called as the more reactive element. For example, here given as the so metal A displaces the metal B from the salt solution, that A is called as the more reactive element and B is called as the less reactive element. So more reactive element always displaces the less reactive element. For example, so here iron plus copper sulfate solution, so here more reactive element displaces the less reactive element plus copper. So here copper is a less reactive element, iron is a more reactive element. Here iron will makes the interchange the position of copper, and in place of copper iron is seated. So this is called as the more reactive element and this is called as the less reactive element. We can say that iron is more reactive than copper because copper is taking the place of copper. So more reactive element displaces the less reactive element. Next, which metal, copper or iron is more reactive according to your observation means we can say that iron is more reactive than copper. So next, reactivity series. Reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activity. So the list of metals are given in the table 2 3.2, that is the order of their activity. After performing displacement experiments, activity 1.9 to 1.9 to 3.12, the following series, table 3 known as the reactivity or a activity series has been developed. So, and while we are having a reaction with oxygen, acid and water, we cannot conclude that the reactive series of metal, but after the displacement reactions we done a some table, so that will gives the activity of the activity, and that will gives the reactivity of the elements. Here potassium is the most reactive element, sodium, calcium, magnesium, aluminium, zinc, these are called as the more reactive element. Zinc, iron, lead, copper, mercury, these are called as the decreasing reactivity, and at the last these are called as the least reactive metals. Silver and gold are the least reactive, these are the moderative, and these are the topmost. Potassium and sodium are the most reactive element. Remember that which is the most reactive element means sodium and potassium are the most reactive metal. This is very important. Remember this reactivity series, so very important. This remember means you can easily answer any type of question on the reactivity series. This table is very important. Remember this table. So the table reactivity of the series, remember that. Next, metal. How do metals and non-metals react? Next question, how do metals and non-metals react means, so in the above activities we saw the reactions of metals with the number of reagents. So metals are reacting with the oxygen, again acid, water, so that is called as the number of reagents. Metals are reacting with number of reagents. Why do metals react in this manner? Why, next, why they are reacting with another metals or another substance or element? Let us recall what we learnt about the electronic configuration of elements in class 9th. So we learnt that noble gases which have completely filled valency shell show little chemical activity. We therefore explain the reactivity of elements has a tendency to attain a completely filled valency shells. Here in 9th class we discussed that what is valency shell. First, what is valency shell means the number of electrons present in outermost orbit are called as the valency shell. For example, here, so this is the nucleus and this is the first shell and this is the second shell. So here, so what is the atomic number of sodium is 11, correct? So 11 means the atomic number of sodium is 11. So first orbit is 2 electron and second orbit is 8 electron, 3, 4, 5, 6, 7 and 8, and first orbit 2 electrons, second orbit 8 electrons, how much? 10 electrons. In last orbit that is having the 1 electron. This is called as the valency of electron. So the number of electrons present in outermost orbit is called as the valency of electron. So again, remember that we already studied that in the 9th class. So the electron, how electrons are distributed in first orbit or second orbit, we have said that the first orbit is a 2 electron, second orbit is 8 electron, and third orbit again how much electron means we already know that by the formula of 2n square we can find the distribution of electrons. So here what is n means number of orbit, n 2 3, so that's called as the number of orbits. Here for 2, in place of you want any distribution of electrons in first orbit means put in place of n is equal to 1. So 1 square is equal to 1 into 2, that will gives the 2. So means first orbit is 2 electrons. So this is the simple equation. So 2n square formula is there. So you want to calculate the distribution of electron in first orbit means you have to place in place of n 1. So that will gives the 2n square is equal to 2 into 1 square, that will gives the 2. And we want to second means to in place of n you have to place a second, that is called as the 2 square, and 2 into 2 square means 4, and that will gives the 4 into 2, that will gives the 8 electrons. And second third orbit, and in place of n you have to place 3, and again that 3 square 9, and 9 into 2, that is 18. we can find the different types of electrons in a different orbit. So in fourth orbit means you have to place, in place of 3 you have to place 4. Again 4 square 16, and 16 into 2 32. The fourth orbit having how many electrons? 32. So this is called as the distribution of electrons by the formula of 2n square. This is I studied in the ninth standard. Again, what is valency? We studied the number of electrons present in a outermost orbit are called as the valency shells. Again, we discussed the noble gas. Noble gas means they are completely filled electrons. They are completely filled electrons in their outermost orbit are called as the noble gas, and they are very unreactive elements because they are very stable, because the elements are in last orbits are completely filled are called as the noble gas.